Hello and welcome to another processing coding exercise, and I'm going to continue on with the theme of parsing structured data, especially data from the internet. So far we have looked at the JSON format, and I've given you a couple different examples of how you can access JSON APIs and then visualize that information. So today I'm going to go through a few things that should be of significant importance for you. I'm going to discuss how to parse web pages. Web pages are structured information, but they don't necessarily look like it because there's a lot of noise there. There's a lot of junk that you need to get rid of, which of course is one of the crucial steps in data transduction. So that's the one I'm going to be focusing on. And along the way today, I'm going to show you how you can use external libraries in processing. There's more than one way of doing it. And by using an external library, we can cut down on the amount of code that we need to write significantly. So first, I'm going to show a sketch that is going to be a brute force approach. It'd be nice if I spelled that correctly, wouldn't it? A brute force approach to parsing a web page, which is to treat it as one long text string. And we've already seen an example of how to process text strings using some of our string functions that allow us to parse out the information and locate information within a string. So this is going to be very much a follow-on to that. But I'll show you the practicalities of it, which I hope will be useful. And then once we have built this, I will move to using a built-in library that will make things much simpler, especially in more complex cases of parsing web pages. So that's what we have ahead of us today. Now, the parsing a web page is sometimes called web scraping because you're just scraping the data off the internet, off the World Wide Web, and getting what you like out of it. And it only works because the data is quite well formatted in what's either called HTML, the hypertext markup language, or XML. So I'm not going to get into the details of the format that much. If you've had experience building web pages yourself, you'll know more about that, and I hope that you have had that practical experience. If not, some of this will be a little bit hand-wavy because I don't want to get too diverted into the complexities of how web pages are formed. To start with, then, I have an outline here of a sketch, and you will recognize this outline as one I've used many times. We are not going to have any real visualization or interaction, so I can say no loop, and we don't need to worry about our draw loop whatsoever. And I'm delegating all of the actual work to a function called parser, just so that I can split it out of the setup. So this is very much the method that I've used over and over again with you. And the website that I'm going to have a look at is my own Media Inspiration Art blog, which you should already be familiar with. And if we have a look at what that looks like, first of all. So first we need to know about our data. So here we go. Here's what it looks like as of today. So there's some title information. There's this left-hand column, which is going to have a lot of complex stuff that we just don't care about. And then there are the posts themselves, and that's what we want to focus on. We want to produce a simple list of the most recent posts on this blog. So what I need to do is find out how to extract this information. So here's one blog post, if I sort of highlight it like that. And then there's another, of course, and so on, all the way down for as many fit on this page, which is quite a few. So what does this look like? Well, we can always right-click on a web page and say View Page Source. And when we do, we will be stunned and amazed, I think, at some of the complexity there. But I'm just going to take, again, a high-level view of this. In the header, so there's two main parts of the web page, the head and the body. And the head has information we simply don't care about right now. It has all sorts of metadata. It has scripting, JavaScript stuff. It has style sheets. We don't care about any of that. So, I mean, one could scroll down a long way before you get out of anything to do with the header. Okay, and then once you get into the page content, there is all of this stuff here, which is all the menus and the stuff down the left-hand column. So how do we quickly find our information? Well, let's find a search string. So this says Seventh Sense by Anarchy Dance Theater. So let's search for Seventh Sense, and we end up here. So that falls inside this class, which falls inside some other ones. And what we're looking for is usually a div, a division of our page. Divs are used to segment the data up into some sort of structure. And sure enough, we have a div here that says class equals post outer. So that seems to define the beginning of the critical information in our post that we need. Now, that took a bit of detective work. I mean, there's a date header here. There's other things on the screen. And then where does it end? Well, it seems to end, this is where the text ends. So then there's a post footer at the bottom, which has all sorts of timestamp and link information that, again, we don't care about. So it seems that this information in here defines a post. So what I might do is copy that out as a template into another file, and I've done that already for us. So it looks something like this. So here's our post outer down to our post footer, and some of the information in between we care about, but some we don't. Look, there's these meta tags. There's this weird ID number with nothing in it. That's not really useful. What we want in particular is the title of the post. We might want the link, we might want other things, but for now, we'll just list the titles. So this gives us, so by analyzing the data, we can figure out what we want, what we don't want. That's always the first step in this sort of, well, the first step is finding the data, and the second step is to figure out what we actually want out of it. And if I simplify this further, which I've again done ahead of time, it looks sort of like this. So again, we have our outer, we have a bunch of stuff. Then we have this H3, a header 3 type structure, which has the title in it. And then we have a bunch of stuff, and then we have the footer. So this really is our overall template. So let's parse this out then. Let's write some code that's going to do this for us. Maybe I'll leave that up there in the background. And what I'm going to do is create a new tab so that I can put all of this out of the way, maybe in something I'll call HTML. And I'm going to build a class then that will do my parsing in the time-honored fashion, where I will need a constructor. And right away I can kind of guess that I want to give it an address. Let me do it like that. So the constructor will take some address, and what's it going to do? Well, it's going to go to that address, it's going to parse out all of the posts, and it's going to store them in some sort of, well, each post is a string, but we need an array of them. So let's use an array list that's made up of strings. We'll call it posts, why not? And we can initialize it to a new array list. Again, we've done this before. We've done this at least twice before, so this should be familiar to you. I guess we want to store our URL as well, our address, where we're getting this stuff from. And something else we're going to need, which is not obvious, is a way of tracking our position in this big HTML file. Because as we progress through it, we're going to want to parse out similar looking blocks, so similar posts. And we want to make sure that we don't accidentally get the same one twice or something like that. So I'm going to store a position in the file. So this is just a number, and we'll start at 0. So we'll start at the beginning of the file that we're parsing. Now we already kind of know how to do the first part of this because we've already been working with text files, and we used load strings to grab the data from an URL or from a file on disk, same difference. And that gives us an array of lines. Whoops, an array of lines. And then what we can do immediately is just concatenate these into our text. So this is our big block of text. We're going to join up all the lines using this delimiter, like nothing. Like we're just going to join up all the lines into a big text string, which is the simplest way for us to begin our work. Every time we're parsing, we're going to need a start and an end string. So I'll just define those here. And the first time we're parsing, let me just get this ready for us. So the first time we're parsing, what are we looking for? Well, we're looking for this as the first thing. And we're looking for this as the last thing. And that in between defines the contents we want, exactly like we did when we were parsing the text of the vampire novel. We found suitable start and stop strings, or start and end, as I've called them here, strings. And okay, so then we want to start going through the file, accumulating all of our posts. But I mentioned a moment ago that, once we've done this, we still need to do more parsing, because then we're going to need to parse out the important stuff from between those. So we actually have to do this more than once. So I'm going to actually create another array list as a temporary place to put our work. We can work through our file. So while some condition is true, now I'm using while because I don't know how many posts there are. I could use a for loop if I had a counter and I knew, we had 6 posts, we could count over 6. So we want to parse out a substring. We don't know how many times that's going to happen, but we want to do it while we still can find results in the file. So I think the simplest way of doing this is to set up some result, a string result, and then in here I can get a substring. So I'm going to create this function in just a moment. Sorry, let me turn this off down here, the console. I'm getting all this stuff. Maybe I can make this a bit bigger as well. Hold on a second. Stretch that out a bit. There we go. Get a substring. From our text. Using start and end. And that will return a result unless there isn't a result. So in which case we should probably have that return an empty string. So what we can say then is if result is not equal to an empty string. So if we have a result, then we can add it to our work array. So something like this. Now, right, let me just create a shell for this. And that's going to object because we're not giving it any parameters. me just set this up so that we can get rid of all our errors. I hate having errors. I hate having those red lights on the screen. Something like that. We'll fix that up in a moment. And it's going to return a string. So it actually needs to return a string. Let me just do that as well. I would just return that. Right. All the red lights are practically gone, except we don't have a condition here. So we definitely want to go through at least once. So maybe what we need is something like this as well. While result is not empty, we're going to do this. So let's just put something in. I'm going to put something in there. So that might look a bit peculiar, but what we're doing is we're just putting some value in result so that we get to go through the while loop at least once. So result's not equal to being empty. And we're going to get our substring from our text, which is all of our lines concatenated together, starting with the start string and stopping with this end string. But if these aren't found, we might have no result, in which case we want to just short circuit and not do that. So this might be a better way of writing this because we have this condition in here twice, but this is the most straightforward. So I'll just leave it at this without getting into other structures that we could use. So this kind of makes sense. It'll make more sense once I write this substring. Now, this is complicated a bit because we can't just go ahead and use the substring method on a string. It'd be nice if we could, but we're going to have no idea then of where we are in the file, okay, in this giant long text string. So the problem is we need to find the first occurrence of our start string. And we need to return everything between that and this. And then we need to continue on and find the next occurrence of this. So that presents us with a little bit of a difficulty, which is solved using this position value. So we're going to keep tracking the position within the file and incrementing as we go so that we never repeat a string by accident. So we can't use the standard substring function. Instead, we have to essentially search for our string manually. So the way that would work is actually let's to prevent confusion, I'm just going to give these other names in here. S end looks like send, S stop. So string, I'll call it string start, hello, and string stop, something like that. So what I want to do then is first, I want to look in our string for S start, but I want to start looking at a certain offset indicated by our position. And that's what this does. And it will return the index of this start string. So the character number at which it starts. So how would I call that? Index. Something like that. So now we know where that string is. Again, the value of doing this is this second parameter, position. So this will not always be looking for the start string from the beginning. It will be looking from this offset through the rest of the file and returning the first time it finds our start string. So if this, if the index is equal to -1, this is a number that's returned to indicate that it wasn't found. So in that case, we want to do this actually. In that case, we just want to return nothing because we didn't find our string. Okay, we always have to return something and it has to match string. So we'll return an empty string. Okay, so otherwise then we have found something And we can advance our position counter, first of all. So say we found something at character 100. We want to advance our position, so our next search starts at 100 plus the length of our start string, so we don't get that one again. And I suppose we could just say +1. We wouldn't have to say plus the whole length, but this is more correct. Right, so this locates the start string. Let me write that in here. Now we're going to want to do something kind of similar to locate our stop string. So this time we're going to search for our stop string. Again, starting at this position, which has just been incremented to be after our start string. So that will keep us safe. Once again, if we don't find it, then we better just return nothing. But if we do, we can continue to increment our position. Oh, not plus. Is this right? Oh yeah, it's the new position. Sorry, yeah, position is the new index that we found plus the length of the stop string. And remember that position is not a variable that's local to this function. Position is a property of the whole class. So this is updating something which a variable POS which is known to the whole class scope. So it will be retained. It won't just be discarded after this function ends. Okay, so we have the beginning and the end. So now we just need to return the actual substring from the beginning, which was index. Oh, I used index for both. That doesn't really make sense, does it? This should be index of the start. Say, it's probably something better to call it. All right, let's just call it start position. So that's the start position. And then we'll have the stop position. Sorry, we need them separate, of course. We can't use the same variable for both because we're going to need them both at the end of the deal here. Okay, so start position, locate the stop string. We have the stop position, and then we can do a substring from one to the other. Start position to stop position, like that. Okay, and that's it. So again, we could have simply used a substring to find the string between start and stop, but that would not allow us to continue through the file progressively. For that, we need to be able to dictate where our search begins each time. So we had to take this more roundabout method of parsing the string. It's a useful technique. It's a bit tedious. Of course, once we have this subroutine worked out, we can just sort of forget about it and never look at it again. So there we go. So this is it's really important to document this though, because this returns a substring, but also as a side effect updates property POS. Okay, that's really important because it's not obvious otherwise that this POS value is being changed by this. Okay, it's really obvious that we have these strings and that we're returning a string, but nowhere in the definition is it obvious that we're updating a position counter at the same time. So this sort of comment is just critical so that you don't forget what a method does. forget its side effects, and possibly screw up your logic. So I think we're pretty well done this. You'll be happy to hear. We've got the substring anyway, so this should now work just fine to parse between outer and footer. So now we just need to continue in a like manner, parsing out this the important stuff from the information in between. So how are we going to do that? Well, if we're just looking for the title, it starts with this, but this is not going to be constant. It's got dates and it's got the title in there. We can't use that because that's only going to return one value. It's not going to help us with the next post we encounter at all. But we could look for this first part, which is not a bad idea, I guess. Let's do that. Let me copy that out. So now we have a new start string. And we have a new stop string. And oh, sorry, I called it end, didn't I? Let me stick with what I have. And the end string, we could just take this, just the closing anchor tag. So this will get us close. This still won't finish things for us because we've got this mess that's still going to be here that we need to do something about. But this will help. So we need some other. Here we had a result. Oh, we can just use the same. We can just use the same variable, can't we? Because all that's done with. So let's just initialize that. Maybe we don't even need to do that. We don't even really need to do that, do we? We can probably just start parsing. So for there's our structure. Whoops, that should be like that. Right, so we're looking through work, and work is an array list. Well, that's kind of convenient then. Because each one is a string. So we can use our special syntax for string s in work. Sorry, typed that in the wrong place. For string s in work, so this will automatically go through each post one at a time. And we want to start parsing, so we better reset our position counter now. And then we can do something very like this. So we're looking in S from start to end, and we're going to get the results of that. And we can presume that there is a result from that in this case, because if everything is well formed, you know, those substrings should be present at all times. And then how are we going to deal with, well, I guess there's this little greater than we could skip the second time. Yeah, so maybe what I'll do is search in result for the greater than to this A. Right, well, I've already searched for the A. I need to change that and use H3. I need to make sure that these are going to be found. Excuse me, so that was a slight deviation. What I need to do instead, the first time I'll search for that so that I still have the other string to search for. It's kind of weird. That's supposed to be greater than. Okay, so just to be clear then, within each post, I'm going to start my search with this content here, and I'm going to end the search with the H3. So what that will give me back is this much. Okay? And then for the second substring, so I'm going to take that result, which is what's highlighted here, And then I'm going to search just for this greater than sign, which closes this link. And I'll use the end anchor as the other string. So this gives us a result, and then I'm searching in result to get, well, I can put it back in result. Oh, I do need to remember each time to reset the position. So, because now we want to make sure we're just searching from the beginning each time. Something like that. And then we can add that finally to our cumulative posts. And that's that. Actually, we don't need anything else here. I think that's all we need. So we're doing a substring search 3 times, gradually narrowing our focus. Let's go back here. Now that we have those results in posts here, the array list, posts, that's all we really need, right? Oh, sorry, that is not being used. That URL doesn't match the variable there. Yeah, we don't even need to save that, do we? We don't need the URL. Okay, so we're just passing it as a parameter. Just clean that up a bit. Sorry. There we go. It's hard to keep everything in mind in one go. So our parsing is now a piece of cake because we just have an array list and we know how to parse that. Kind of just did. Oh, we haven't instantiated anything yet, mind you. Right, getting ahead of myself. Right, so we have an HTML parser. Let's call it Mia. Whoops, parser. And so that's a new HTML parser. And we're going to send it our URL so that it does all the parsing immediately. And now we can loop through the posts in that instance. And for each one, we can output it to the screen. And then we can, as we did before, we can increment our Y position. And that'll work. That should work fine. Text, sorry, I didn't put the open bracket there. That should work just fine. So let's initialize our X and Y positions, say to 40 pixels. Give ourselves a leading of maybe 20 pixels. This is supposed to be posts, plural, I guess. Yep, it was. Okay. And let's put some header in here so we know what we're printing. Another text. So most recent posts on Maya. Something like that. Now I'm very keen to run this and see if it works. I don't have any errors here. I don't have any red lights on. Let's see what happens. Takes a moment. Aha! Almost right. So most recent posts, and it's listing all the titles. It's not quite parsing correctly. It's got an extra, it's not parsing past the greater than for some reason. Not too sure why that is actually, because we told it to. We told it to parse past the greater than. Interesting. Interesting. Yep, that's our data. I wonder what I didn't get quite right there. It looks like there's a counter wrong. That's what we're using in here. If we put a +1 here, I don't see why we'd need this. Curiouser and curiouser. Yeah, that actually works. I'm not sure why we would need +1 though. It's probably something to do with zero-based indexing. So that's a bit curious to me. Yeah, maybe that makes sense. Maybe that makes sense. Well, it works now. It works now anyway. It could be the difference between 0 and 1 based indexing. So if the start position is 20, we actually need the 21st character in the string to be returned. So yeah, that's a good example of trial and error debugging. In any case, let me not take any more of your time over this particular example because I would like to move on to the second example. I hope you can see that this is a tedious and error-prone process. I do not recommend that you parse HTML as if it's just a mass of text looking for strings. The problem with this method is that it has no knowledge of the formal structure of this document. It's pretending it's a dumb string, and it isn't, because web pages are structured according to what's called the document object model. So what I'll like to do now is, let me close that. Here's where I'm saving my work, web parsing. It's got web parsing in HTML. So what I'm going to do is duplicate this to start another project. Copy and paste. Web soup, I'm going to call it, for reasons that will become obvious in a moment. And I'm not going to be using the HTML anymore. Web soup had better be the name, of my sketch as well. So let me launch that and get rid of this. Well, I won't get rid of anything right now. I'll go through step by step. So this will be an approach to parsing a web page using a library. So what I'm going to do is show you how to do that. Now, if you're looking for a particular library, the number one thing that you would do is go into your sketch menu. Under import library, you can add library. And there are quite a few here to choose from, which are already configured for instant installation into processing. And you can see that some of them are grayed out because they're currently not available. Others have a red check mark, Sound and Spout I have, because I've already installed those previously. But in other cases, they're available for us. Now, if you can get a library this way, it's by far easier. It turns out that I found this, let me close that down now. I found this library called JSoup, and it says it's a Java HTML parser. And yeah, it's a Java library for working with real-world HTML, provides a very convenient API for fetching URLs and extracting and manipulating data using the best of HTML5 document object model methods and CSS selectors. Okay, sounds like what we want, right? And here's an example of grabbing a Wikipedia page and getting some title information from it. And it takes only that much code. So thumbs up, I want this. How do I go about making this work? Well, is it available here? Let me search JSoup. No, it is not one of the standard libraries in this program that's called the Contribution Manager that we can install. Okay, next is, do we want to install this across our entire install of processing? And if you're working on a computer that you know you get to work on time after time, as I am here in my home office, then that's not a bad idea, because I might want to write 10 or 20 different programs using JSoup. So installing it across my processing install would be the way to go. And to do that, I download the, well, let me go back to the website. To example, getting it, so download. So I'd go here, I would click the core library, yes. Keep, and it is already done. So it's downloaded that in the background. So let me just copy it onto here. So here it is. It's jsoup-1.13.1.jar. So jar files are how Java libraries are packaged. Now, you can read up on how to install that in processing. It's not very difficult. You simply have to put the right files in your libraries subfolder. But I'm going to use a third method. So the third method is if you only want to install this in this sketch. And this is what I want you to do if you're using any libraries for your assignments. Because if you don't install it in the sketch itself, then you don't have an easy way of giving me that work. So how do you do that? Well, you drag it to your sketch. You just move the jar file and you click and drag to here. And what that does is it creates a code folder with the jar file inside. So you could certainly do that manually. You could create a code folder and put the jar file inside. We don't need this one here anymore. I'll delete that. Or you just move it to your window. Now that means that this library is only available for this sketch. But it does mean that when you zip up all your work here to send it to someone, they're going to have the library as well. And your code should work the same. You can have confidence that will work. So this is the recommended method if you want to distribute your application and be sure that the end user can run your program correctly. Okay, so no matter how you install the library, the next step is to be sure that your sketch knows about the library and it knows about the components that it's going to need to access. And the way you do this is with import statements. And again, if you use the built-in library manager, then you can generate these import statements, say for SVG. I just clicked on it and it put the correct import statement there for me. But if you're manually installing, as we did, a library like JSoup, then you're just going to need to look at the docs to see what those are. So delete that one I'm not using. And these are the import statements I need. Then I just copy and pasted those out of the docs. So this makes available all the components of that library to my sketch. It's a very standard approach. Now most of this can, all this can stay the same. I mean, I'm just going to have the same top level sketch here. What I, of course, will need to change is how I'm doing the parsing. And I won't need any extra classes or sketches that I write myself because it's all in this library. Now, definitely the way to approach this is to do a document-based approach. So if I go back to the home page, it has an example here of how you, I mean, this isn't a full example, but it does show how you can go about connecting to resources and extracting information. So let me just look at the first line there. Copy that. I no longer have HTML parser. Let's get rid of that one. I probably want these here still because these are just here to help me with my display. So let's start down here and do it very similarly to the example. So this is our URL. Whoops. And we use this syntax. So we connect to our URL, and then furthermore, we use the get method on that. So that's actually two operations in one. Now, what if that fails? You probably want some code to catch any exceptions that occur, but I think I'll skip that for now just to keep things simple, and maybe I'll put it in the code that I provide for you as an adjunct to this lecture. It's always good to have error catching code and as much as possible protect the user from errors, give them advice on what they can do if there is an error and so on. But I haven't been emphasizing that sort of rigorous rigorous approach. So that's our document. Now, how do we use the document? So we're going to use the document object model to parse using JSoup. So how do I use a document object model? Well, in a way, it's very similar to what we were looking at before. So, so in this file, we have these divs, which are elements in our HTML, and they are defined by particular class names, or they can also be defined by particular IDs as well. Or we can actually look at structured portions of this document by tag. So the A tag or the H3 tag. So there's at least 3 different methods that we can use. And depending on the part of the file, the part of the document object model, we have to use one or the other. So there is this terminology, and you definitely need to look up a little bit in the documentation for this library. For example, you need to know that the correct data type is called elements. So let's extract all our posts first of all within our document, our doc, and we're going to get elements by class. Elements, get elements by class. And what class were we looking for? Well, I have it up here, don't I? Class, it was post outer. Move this out of the way a bit so I can click from one to the other a bit easier. So you can already see a difference here. We don't need to put in a big string. We can refer to stuff by class name, and that parsing is done behind the scenes. So this line automatically gives us all of our posts, because it gives us every instance where there is a class called post outer. So then within that, we can parse. Again, we're not using strings or stringless, we're using posts now. So for every element P in posts, so you can see there's elements, which is a list of elements, and there's a single element as well. This is all part of how JSoup, the class structure of JSoup, how it internally organizes our data. And then just so I don't need to type endlessly, I'm going to repeat this line. So next, we want to grab the next class here is post title, right? So this is the next part, the H3 subdivision, which is called post title. It's also called entry title. It actually has 2 different classes there. We can use just the first one though. So here we're going to define elements, our titles, and we're going to get element by class, post title. Simple, same thing. And except that is not within the whole doc, that's within each post P. So within each post, we're going to get the title, and there should only be one title, but we don't know that. There could be more than one title. That's why we have elements. So then we need to just keep this iterative process going. So for every element title, inside titles, and there should be only one. There should be only one title, but we don't know that yet. Let me scroll down here. Now, what do we want? Now we want, within this highlighted string, now we want the contents of this. Again, all of these have opening and closing tags, so they're defined quite clearly. So this is not, this doesn't have that word class equals in here. This is a tag, so we need to use a slightly different way of extracting it. Whoops. So we've got titles, and now we want our links. Again, there's only one link within a title, but we don't know that in the general case. So let's look within title and get elements by, not class, because there isn't a class, by tag A. And that gives us our links. Now it should come as no surprise that now we need to loop through the links. So for link, for each element link within links, links, we can do something with them. Well, we found what we want. We've actually found what we want finally. Finally. We can print it out just as before. And then make sure that we have, yeah, we're missing one. Make sure we have, all the matching braces for each of those 3 loops. So, okay, just to be consistent, I'll change that from P to post. Put a few spaces there. Right, that's the sum total of our code. I hope it looks simpler than what we had before. It's certainly more organized because the hierarchy of the structure is extraordinarily clear. We have our outer level is a class called post outer. Within that, we're going to look for every post title. And in our document, there should be only one, but this is the way we should do it. We should return all of them and then loop through the titles and look for an anchor tag within each. And again, there should be only one, but it doesn't hurt to loop over them and print each one out. And this will happen over and over again until our document is exhausted. So we no longer keep track of our position. That's done for us. We no longer need to do substring parsing. That's done for us. A lot of mess is taken care of. All we need to understand is the document object model, which class is within which class, and which tag is within that, in order to drill down to the actual information we want. And it'd be very easy now to extend this and not just pull out the title, but we could pull out the text and the links and everything else because they are all clearly demarcated in the document object model. Now to prove this, I'm going to save and I'm going to run. And it says, what the heck is S? Don't you mean link? Oh yeah, that doesn't quite work. That's of type element. We need to print a string, of course. So it turns out that there is a method to extract the contents of that as a string, and it's called text, which I'm quite familiar with because I've done this a few times. This is unhandled exception. Interesting. Okay. Well, now we're going to learn something new then, as the final part of this lesson. We're gonna learn how try catch finally blocks work, and let me write it for you first. So a try catch is a particular structure that's used when we want to handle errors that might be unexpected. So it's quite a sophisticated way of doing it, essentially, where we try this and we catch any errors. Now, down here it said unhandled exception type IO exception. So that is the error IO exception. That's the error type we need to handle. So let's call it an error like that, right? So we need to specify here the error type, but thankfully we were told what it was in the red error message. And once we have that error, there's like a little suite of utilities that we can use to to handle it. So you can look these up in the docs, okay? Print stack trace. Yeah, print stack trace, something like that. So now what's it complaining about? Oh, now I've defined the document within this scope, so it's not known outside the scope. So that actually is a problem. I need to do this in 2 stages now. I'll just define it up here and use it in here. That is more correct. It still doesn't like that. May not have been initialized. Ah, wow, this is so smart. The error checking is so smart. Because look, we're going to try to connect to our URL and get the results into doc. If it doesn't work, we're going to handle an IO exception, and we're going to do that by printing out a stack tracing so we can see the error listing. But in this part here, doc is not defined because we had an error. So we need to define it. And now that's gone. Now it's no longer red. So this is defined. Now, mind you, if we have an error, just simply retrieving our URL, we're certainly not going to be able to do all this parsing. So probably what we need to do is short circuit our program. So we'll just return. We'll just get out of this routine like that. So we'll attempt to connect to our URL, and if successful, the results get put in a structured way inside this document class doc. If we do have an error, it means doc was never well formed, so we'll just put null in it. Null is our handy value. We use sort of like an empty string, but we use it when we're not dealing with strings, but other instances. And then once this is over, we had better check, because if we have null, we need to just return and not try and do all this, because this will just produce more errors, of course, if we were unsuccessful accessing the web page. So I went over that fairly quickly, but this is a standard construct in Java that's used to handle errors. You can use it all over the place to handle any type of error you wish. Let me see if this runs now. Yes. There was a bit of a pause there, but if you recall from our previous example, there was also a bit of a pause because we are in fact retrieving this over the internet. And that worked first time, which is kind of nice to see. So I'm going to leave it at that, just so the video doesn't get too long. I hope I've demonstrated the utility of using the correct library for each task. And I've shown you how you can easily install that library for this sketch under a code folder. And again, the jar file that you get, you don't need to extract that or do anything to it. You don't need to get rid of these version numbers afterwards. It just works. The mechanism for that is quite robust. So just chuck your jar files into a code folder, and then you can access them with import statements in your sketch. And other than this little song and dance we had to do here to be sure we didn't have an error, the parsing is quite simple. It's recursive for loops as we drill down to each level in the document object model. So I hope this has proved useful. You can now try scraping websites, Wikipedia pages, whatever else, and extracting the data. I urge you though, like all such cases, do not spam websites. Do not have a program that's going to be scraping the website 1,000 times a second, because you might very well get yourself or your internet provider banned. So just, be a good net citizen in that respect. Yeah, and if you have any questions, we can discuss those the next time we meet online. This code will be provided for you so that you can try it out yourself. But I hope that you take the time to follow through, write it yourself, come up with another website that you want to attempt to grab the data from, experiment, and find something fun to do with the web. This is Robin, over and out.